Hello everyone. In our previous two videos, we provided an explanation about identifying the failures of mechanical parts in unmanned aerial vehicles and how to repair them. In this video, we will delve a bit deeper into troubleshooting the electronic components. Our main focus here is to look at what causes failures in electronic components and what their sources are. In this video, we will cover the troubleshooting of our electronic parts a little more. The main point here is to look at what causes failures in electronic components and what their sources are. First of all, our electronic components have a certain lifespan and usage conditions. For example, let's say you are using motors that cannot operate in rainy environments. If you run this drone in a rainy setting, your motors will likely fail, and that could lead to a crash. These are products that have specific operating conditions. For example, if you are using motors that cannot operate in rainy conditions, when you run this drone in a rainy environment, your motors will likely fail, which could lead to a crash. The most important point about the electronic components on the drone is to pay attention to the operating conditions. For example, the receiver connected to the flight control board we are using here has there is a range of use. Flying in cities reduces range. Exceeding this range disconnects the drone. Without software intervention, it will descend. If you try to fly the drone outside of this range without paying attention to it, the connection between your drone and the controller will be lost. If there is no intervention in the software within your flight control board during these connection losses, your drone will slowly descend and land in an empty area. Worse yet, it could crash into a building or even hit a person. In short, we must first pay attention to the operating conditions of our electronic components. Worse yet, there is a possibility of crashing into a building or hitting a person. In short, we must first pay attention to the operating conditions of our electronic components. The second point is that the electronic components of our drones must undergo periodic maintenance and checks. Again, these checks need to be done before and after each flight. For example, our motors reach a certain temperature due to usage, at 60 degrees, on its body, but this heat temperature is in a class that you can touch with your hand. If the temperature of your motors is too high, when you land, then you should check your motors and consider replacing them, if necessary. We will go through 4 main points for checking our electronic components. What we mean by these 4 main points is as follows. Let's actually start the control of our electronic components with 4 pieces of equipment. These are our equipment that make up our propulsion system. The first one is our motors. Our motors are classified as brushless DC motors, and they allow the use of outrunner. What we mean by outrunner is that the rotor part, or the rotating part, is on the outside. The stator side consists of the windings inside. They remain stationary and generate magnetic energy. We ensure the rotation of our motors by controlling this magnetic energy. The most important thing we need to pay attention to here is that our motor's windings are adjusted very precisely, and in fact all the label values you see here have emerged from these windings. So if you make any adjustments to the windings, you could end up outside of these label values. Let's think about it. We detected a fault in 3 out of our 4 motors, and we intervened in all 3 of them. This time he has taken all 3 of these label values out of the equation, and somehow we may have disrupted the operating conditions. Therefore, if we detect any faults in the motor, whether in the outer layer or the inner layer, and if you don't have professional equipment, or if you don't have much knowledge about motors, or if you think they can't be repaired, it is highly recommended to replace your motors and use new ones. After we remove our motors from the body, if you see any discoloration on the inside or outside, it indicates that our motors have burned out, and they definitely need to be replaced. After removing the motors, check for discoloration inside or outside, indicating burnout and the need for replacement. If turning the motors is difficult, there might be a short circuit in the windings, requiring replacement. Inspect your flight area for dust or debris that could be inside the motor windings. Remove any objects to test the motors. Checking your flight and confirming flight conditions, you can check for objects in motor windings. Remove any objects to test motors. Check with PVR controllers. Then complete assembly and repair drone. If there is an object or item inside the motor that you can remove by intervening, take them out to test your motors. After checking with PVR controllers, which are signal generating devices, you can complete the assembly and finish the repair of your drone. Our second point is the ESCs you see here. Our ESCs have a total of 6 wires. 3 of these go to the motor, and these are our power cables. 2 of them go to the battery. The wires in this battery are actually the ones that carry high current and high power energy. The wires that have passed through are quite delicate, so they can wear out quickly or even burn out. They can be affected in any open circuit situation. The cable you see here is our signal cable, and it goes directly to the flight control board. The ESCs here are actually PCB electronic boards. When it burns, there is probably a capacitor or some kind of resistor and an electronic device that may have burned. Therefore, when you want to open the ESC and check it, you can first remove the outer casing and visually inspect it for any signs of burning. The electronic device may have burned out. As a result, when you want to open the ESC and check it, you can first remove the outer casing and visually inspect it for any signs of burning. After that, to determine whether the problem is caused by the ESC, you can perform short circuit tests using a signal generator or a multimeter. If you have electronic knowledge and possess the electronic components to replace the resistor, capacitor, or diode, such as high-quality soldering kits and magnifying tools, then you're set. You'll also need small micro tweezers to be able to take them out. And similarly, when placing them, you need different types of solder wires and liquid solder types. You can use it by changing it like this. However, if you don't have such knowledge, it's best not to take risks and to replace your ESCs, including the faulty ones. You can also send your broken ESCs back to the factories or the manufacturer for repair. Our third component is lithium polymer batteries. You can send the ESCs back to the factories or the manufacturer for repair. Our third component is our lithium polymer batteries. Our lithium polymer batteries have a total of 2 wires. The 2 wires here are our power cables. Lithium polymer batteries are made up of cells by their very nature, and we need to measure the voltages within these cells. Why are we measuring these voltages? The data we obtain from these voltages during the charging or discharging phase is very important for us. If you see a difference of more than 0.30 to 0.40 volts between these voltages, you can say that one of the cells in our batteries is aging or has failed. You can check the cells of our batteries through the connector you see here using a multimeter. Based on the values you measured with the multimeter, if one cell is below 3.5 volts, then you will determine that that cell is dead. Or if one of your cells is showing a certain voltage and the other cell is showing a different voltage, then we can say that your battery is aging and actually needs to be shocked or replaced. Our other equipment is the flight control board. Our flight control board is our main brain. They are actually devices that can store issues and errors that may occur during operation in a black box. How do you detect errors in the flight control board before a flight? First, you can go to the mission planner screen, which is your interface screen, to simulate whether the sensors on your flight control board are working correctly. As a result of this simulation, let's say that if it shows you at a higher or lower altitude in the ground position, you can identify which of the external and internal sensors within your flight control board capable of detecting your drone's position on Earth and its altitude is malfunctioning. Since the flight control board is a very complex structure, if you detect any malfunction here, you need to replace your flight control board. Our GPS also has a quite complex structure. Here, it connects to our flight control board with a single cable. Since it is above the body, our GPS may be damaged in the event of an accident or breakage. And because it has sensitive sensors on it, repairs are often not very feasible. Repairs need labs, use resources for reuse. These are devices that can be done in large and advanced laboratories or technology workshops. Therefore, you can replace them with the existing resources you have and ensure their reuse. On this side of the video, we generally covered our electronic components. How do we detect a malfunction in the general electronics of the drone? You can also check the power cables inside the drone with your multimeter. If you want to determine whether the motors are not getting enough power, or if your drone is not working, or why it has burned out, you can perform an open circuit test with a multimeter. Before performing this open circuit test, you need to visually check if there are any exposed wires. If you haven't detected any exposed wires, you can start testing all the power cables on the drone one by one, beginning with the motors, and then take notes to identify the source of the malfunction.